For this example, this is saying the annual interest rate on a credit card is 24.99%. If a payment of $100 is made each month, how long will it take to pay off an unpaid balance of $2,487.56? Assume that no new purchases are made with this credit card. Okay, so here, this is saying how long will it take to pay off this balance. So when you're paying off a balance, what's happening to that account, that balance? The account is going to zero, and remember, when the account is going to zero, we have a PV problem. Okay, I know it's obvious that 3.4 is only PV problems, but again, on the exam, you will not be told which problem this is, so you're going to have to look for those key indicators. If the account is going to zero, it's a PV problem. If the account is increasing in value, then it's a future value problem between the two types of annuities that we've been dealing with. Okay, so now that we know that it's a PV problem, so write out that formula. And now let's figure out what we know. Interest rate, that's going to be 24.99%, decimal 0.2499. This is saying, hey, how long is it going to take to pay off this unpaid account? Well, time, we do not know. Our payments, well, we're sending in $100 each month. The account, how much we're in debt, well, that's the $2,487.56. And these accounts, these payments are being made each month, so M is going to be 12. Okay, so substituting what we know, we get PV. PV is going to be $2,487.56. Our payments are 100. 1 minus, 1 plus, 0.2499. Divide that by 12, raised to the 12 times. T we do not know. All over 0.2499, divide that by 12. Alright, so here we have an exponential equation because our variable is in the exponent of, well, it's in the exponent of this entire math expression right here. So eventually we're going to want to isolate this math expression because its exponent contains that variable we're solving for. Alright, so let's simplify everything before we start moving math expressions, numbers around. So the left hand side, we can't do much about that. Here we're going to have 1 minus. And so we're going to go ahead and punch this into our calculator. That's going to be 1 plus 0.2499. Divide that by 12. And that's going to give us 1.020825 raised to the negative 12t. All over, and then we can simplify this. This will be 0.020825. Alright, so I'm going to keep highlighting the part that we're going to isolate. Okay, so this math expression, its exponent has that variable t that we're trying to solve. So we're going to isolate that. So let's get everything else around it out of there. So for this big parenthesis, I can actually divide both sides by 100 because that's multiplication by 100. And those will cancel. So here on the left hand side, I am going to get 24.8756 is equal to, then we're going to have 1 minus 1.020 825 raised to the negative 12t, and that's going to be all over 0.020825. Okay, I'm going to keep highlighting the part we're trying to get all by itself. Alright, next, we're not going to want to take care of this one yet. Okay, we have to get rid of this division first because we're still following the orders of operation. So I'm going to go ahead and multiply both sides by 0.020825. Those are going to cancel, and I'm going to go ahead and do that to the left. Alright, the left hand side, we are going to multiply that decimal with 24.8756. And that's going to give me 0.5180337, and that's going to be equal to 1 minus 1.020825 raised to negative 12t. And let's keep highlighting the goal that we're trying to isolate. Alright, here I have a 1. Now that's not a negative 1. Okay, that negative symbol applies to what I have highlighted, right? The sign of this one is in front, and if it's invisible, it's positive. So I'm going to go ahead and subtract both sides by 1. Those cancel. And then on the left hand side, I'm going to have negative 0.48196.563. And that's going to be equal to negative 1.020825 raised to negative 12t. And then if I divide both sides by negative 1, those negatives are going to cancel. So we are going to have and we've isolated that part, that 1.020825 raised to negative 12t. Okay, so this is an exponential equation. We've isolated the math expression that's being raised to the t power. So now we can go ahead and log both sides, and this time I'm going to go ahead and just ln both sides. Remember, you get to choose. This time I'm going to choose ln, natural log. So the left hand side will be natural log 0.48196563 equals, use your power rule for logs, and then last step, we'll divide both sides by negative 12 ln 1.020825. Alright, so those all cancel. I'm left with t. And remember, when we're inputting this into our calculator, you're going to want to look for the ln button. It's going to open up a parenthesis, 0.481, blah, 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 blah. Close parenthesis, hit the division symbol. But remember, last time I said you have to put a parenthesis or else your answer will be wrong. Okay, and then you'll enter negative 12 ln. It'll open up a parenthesis for you, 1.020, blah, 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 blah. Close parenthesis, and then close that important parenthesis. And that should give you 2.95 years. Okay, so final sentence, it will take 2.95 years to pay off this credit card.